Lesson 35, Hypothesis Testing Procedure for Two Population Means. Example 3. The reaction time of a test subject is measured by having them stand and place the palms of their hands on the surface of a table, equally spaced on both sides of a reaction timing device. When initiated, the device will display a red light, and after some random interval, the light will change to green. The test subject is instructed to tap the screen of the device with their finger as soon as they see the green light appear. The reaction time is the total number of milliseconds that transpires from the moment the light turns green, which is the stimulus, to the moment the test subject taps the screen of the device with their finger, which is the response. The reaction times for a random sample of 33 men produced a mean reaction time of 439.8 milliseconds with a standard deviation of 31.7 milliseconds. The reaction times for a random sample of 37 women produced a mean reaction time of 480.1 milliseconds with a standard deviation of 42.6 milliseconds. According to these results, is there evidence to clearly suggest that there is a difference in mean reaction time of men and women? Well, there's two possible answers to this question. Either yes, there is evidence to clearly suggest, or no, there is not. To answer this type of question, we will be conducting a hypothesis testing procedure, because here we'll be able to determine if either yes, this idea is valid, or no, this idea is not valid. Now, this idea wants to know if there is evidence to clearly suggest that there is a difference. So a difference would mean not equal. In the mean reaction time, which would be mu, of men, which is one population, and women, a second population. So the statistical form of this idea can be expressed as mu1 not equal to mu2, where 1, the first population, would be the reaction time of men, and 2, the second population, would be the reaction time for women. Mu1 not equal to mu2 would indicate that yes, there is a difference. So we'll be conducting a hypothesis testing procedure involving two population means. So we look to the following as a guideline to take us through the steps of the hypothesis test procedure, starting with the stating of the hypothesis statistically. Here we've indicated that the mu1 not equal to mu2 indicates that yes, there is a difference. The opposite would be the mu1 equals to mu2, which would indicate that there is not a difference. The mu1 equals mu2 contains the condition of equality, and HO is always used to label the condition of equality. And H1 is always labeled with the condition of the non-equality. So here, the statistical form of this hypothesis test is HO mu1 equals mu2, which leads to the answer of no, there is not a difference, versus the alternative H1 of mu1 not equal to mu2, which leads to the conclusion of yes, there is a difference. After the hypotheses have been set up, we then identify alpha, the level of significance. Here we're going to use the customary alpha of 0.05. Next, 2-samp t-test. That's the command on the TI-84 calculator that will calculate the p-value that we need to reach our decision. But to calculate the p-value, we need our sample results. So when we're told that we have a sample of 33 men, and men was the first population, the sample of 33 would be N1 equal to 33, our first sample size. And when we're told this sample produced a mean reaction time of 439.8 milliseconds, we're given that the mean for this first sample, x bar 1, equals 439.8. With a standard deviation of 31.7 milliseconds, tells us that our sample standard deviation for this first sample, SX1, equals 31.7. Now when we're told we have a random sample of 37 women, women being our second population, we know that the sample size for our second sample, N sub 2, equals 37. And this sample produced a mean reaction time of 480.1 milliseconds, thus telling us that the mean for the second sample, x bar 2, equals 480.1. With a standard deviation of 42.6 milliseconds, tells us that our standard deviation for the second sample, sx2, equals 42.6. Thus, we have our sample statistics that we can use to enter into the TI-84 calculator. Notice here, both N1 equals 33 and N2 equals 37 are sufficiently large. So on the calculator, we could press Stat, arrow over to Tests, and then down to t-test. Enter. Now for input, we have the actual sample statistics. So we arrow over to Stats, press Enter to select. Then down arrow. We enter in the stats, starting with x bar 1, 439.8. Enter. And then sx1, 31.7. Enter. N1 equals 33. Enter. X bar 2 equals 480.1. Enter. Sx2 equals 42.6. Enter. And N2 equals 37. Enter. Now H1 contains the not equal inequality. So not equal is selected. Pooled is no because we're not doing the pooled approach. Down to calculate, enter, and we get the resulting p-value. So in this case, the p-value equals 2.6 e minus 5. That is, the p-value is represented in scientific notation. The e minus 5 indicates that the decimal place here between the 2 and the 6 really belongs 5 places in the negative or to the left, and then the blank spots are filled in with zeros. But p-values being probabilities, we just need to round it off, carrying 3 places after the decimal. So this p-value rounds to 0.000. Now that we have our p-value, we can make our decision. Since the p-value of 0.000 is 0.05 or less, the decision is to reject HO. When we reject HO, that means we have enough sample evidence to indicate that HO is not valid. And if HO is not valid, the opposite idea, H1, is valid. Here, H1 states that mu1 does not equal mu2. And mu1 not equaling mu2 indicates that there is a difference. So we do have enough evidence to indicate that there is a difference in these mean reaction times. So, based on the results of our hypothesis test procedure, we can reach the following conclusion. Therefore, according to these results, there is evidence to clearly suggest that there is a difference in mean reaction time of men and women on the average. Now, this is not saying that all men and all women have different reaction times. This is a statement about the mean reaction time for the population of men and women. So individually, men and women will have different reaction times. But overall, on the average, the mean reaction time of men and the mean reaction time of women for the whole population is different.